Hi everybody, it's Kyle Baley again. This is the third in a series of screencasts on brownfield application developments. We're talking about setting up the ecosystem for your application to reduce the friction on your developers to keep them focused on the code. In the first one we talked about setting up a tree structure in your source control system that is flexible and also reduces the friction for your developers. In the next one we did the check-in dance, how to ensure that the code in the source control repository is good, quote-unquote good. In this one we're going to talk about automated builds, how to automate the building of your application, whatever your definition of build is. You didn't see me, I put little double quote marks when I said build. Now, some of you may be familiar with automated build products and you think that I can't really get through it in 10 minutes, around 10 minutes. Well, you guys are liars. We can get through it in 10 minutes. And the way we're going to do that is by talking really fast and by using a product called Tree Surgeon. It's an open source product on Codeplex. It's codeplex.com/treesurgeon. And as you can see from the description, it's used for creating a brand new development tree. Okay, now that's for what sounds suspiciously like a greenfield application, because that's what it is. It'll create a brand new development tree for a greenfield application. Okay, how does that relate to brownfield applications? Well, stop asking questions and I will tell you. The GUI is pretty simple. Specify the name of the project, which version of Visual Studio, and click Generate. It says, this is where I've generated your tree. I'm done with Tree Surgeon. And it's created in the folder that it specified the full source control, a solution file, a console application to start with, a unit test application, and a core application that you can use to start creating your application, your brand new greenfield application. I'm not interested in that because I've already got an application. It's a brownfield app. It also creates an automated build file with using NAnt format. Now, that's the only thing that Tree Surgeon supports right now. The other build file formats are, say, you can use MS Build. There's the Boo build system called Bake. There's also, I believe you can use Rake. I don't have any experience with Bake or Rake and only limited with MS Build. So luckily Tree Surgeon is going to work for me. It's going to create this build file, which we'll take a look at shortly, a batch file used to launch it. We're also going to include the tools here. Let's copy all three of these over into my real brownfield application. Okay? Quick note about the tools. In the first episode in this series, I talked about the lib folder. This will contain all third-party libraries that are used to run your application. Okay? They're not libraries that you have control over, but you have references to them in your application, and I said you should include them in your source control repository to reduce the time it takes for brand new developers to get started, and to allow existing developers just to blow away their code and get the latest version from source control. Now, tools are similar in that they're third-party libraries, but they're not necessary to run the application. Rather, you use them to build the application. Okay? In our case, we're using NAnt. So in our tools, we're going to include NAnt, as in all of NAnt. The executable, the config files, all of the dependencies it's got. In our source control, we're going to include NAnt, again, so that somebody who is first downloading this application, the source code from the repository, doesn't need to go out and install NAnt, doesn't need to go find it, figure out which version we're using. They just download the entire application and click Go, and it'll build the application for them. Now, Tree Surgeon includes NAnt in its tools. It also includes NCover and NUnit, which I am going to delete for now. You shouldn't really, but we don't have any unit tests yet, and if I don't delete them, this will take much more time than I'm allotted to get into my source code repository. Let's take a look at the batch file. Pretty simple. Calls out to NAnt, specifies the build file that you're using, and it also passes along this %* means that it will pass along any parameters that you've specified to NAnt.exe. NAnt has some other parameters you can pass in. The most notable one is that you can pass in a specific target. It's got the concept of a default target, but you can also specify a different one. I'm going to add a pause here so that I can run this, just double click it and run it and see what's going on. Let's take a look at the build file. The build file is an XML file, and I'm going to format it as such. This is NANT's format, the NANT schema, and by default, when you run it, if you don't tell it to do otherwise, it's going to use this test target. Now, a target is simply a task that runs in NANT, and here is one such target called test. Here's another target called clean. All it does is delete a directory if it exists. Okay? The test target doesn't actually do anything, but it depends on the compile and run unit tests target, which means that it's going to make sure that these two targets have run before this test one will run. It's kind of a higher level thing here. Now we've got a run unit test target down here. We don't have any unit tests in our application. There is one in the one that Tree Surgeon created. So I'm going to change the default here to compile, because that's the only thing we can do so far with our application. The compile target calls out to msbuild. This is a NANT task that calls out to msbuild. Specifies the solution file that you want to compile. Now, Tree Surgeon is going to create the solution file in the source folder. We have ours at the root. It's also going to say use this configuration. Tree Surgeon is going to create a project with an automated debug configuration. Ours doesn't have that configuration, so I'm going to delete that, and I'll just use the default one, which is debug. We can change this afterwards if we see we need another configuration. So now when it runs this build file, if we don't tell it to do otherwise, it will run the compile target, which simply compiles the application. We double click on go to see if it works, and of course it will, because this is my screencast and I wouldn't be showing you if it didn't. Build succeeded. You can also run this from the command line. Oops, I'm not in the Twilight Stars. Go. The name of the batch file is named so as to allow you to type that often. Go. Okay? And that's the important thing about an automated build. It needs to be fast, because the elapsed time is less than a second. You need to make sure that your build file stays pretty quick to allow developers to run it often, okay, as much as they want. We now have a very basic batch file and a very, very basic automated build file that at this point all it does is compile the application. In later episodes we're going to get into continuous integration and in running unit tests. What I need to do now is add this to my source control. You can see I included the tools. And now let's commit. Okay. We now have a very basic automated build process that will compile the application, and you can see that we can build onto it from the build process. You can see that we can also delete directories from it. We can run unit tests. We can build distributable packages from it. In this case, it'll create a zip file, or we can create a package that can be distributed or deployed to a web server, for example. So very powerful. We'll expand on this build file in the screencasts to come. And the important thing is that it runs very fast, and it's something that can be launched from another process, which is kind of foreshadowing for our foray into continuous integration. Okay, you can see already that this could be run as a scheduled task, say on a nightly basis, to ensure that at least everything that's in the source control repository is compilable. Okay, we're still uploading here, and I'm not going to bore you with this, but I will say that, again, those of you who said I couldn't cover this in 10 minutes, you're still liars. We now have a build file that will compile the application for you, which at this point is all we really need. So until next time, Billy says, code strong and we'll catch you on the next screencast.